Hello everybody, and welcome back to Ask Math Anything. I guess it's Halloween, so does that mean that these are all of the people who are watching today who didn't go trick-or-treating? I guess that means we'll do some tricks or treats in math. Alright, well, if you haven't been here before, the way that this works is that anyone who has some interesting questions to ask about mathematics, feel free to type into the chat. And what I'm going to do is I'm going to try to pick the questions that seem maybe most interesting to people who might be learning about algebra or geometry for the purpose of math competitions. Of course, that includes areas of math which are outside of that too. Maybe we'll end up talking about things with number theory, or maybe we'll even talk about combinatorics. Let's see. But in order for this to work, we actually need to have some questions in the chat. Now, I don't see the chat moving, and what that means is maybe I need to refresh my window. I'm just going to try that here, because usually the chat's moving by now. Let's see what happens. I did see someone say, imagine going trick-or-treating. Let's see. What else do we have here? And the purpose of this channel is just to have a chance for people to ask questions. Yeah, dead chat. That's true. Hello, sir. Yes, hello there. And the point here is that if there are questions that people want to talk about, we can do this. From where are you? Well, right here I'm in Pittsburgh, Pennsylvania. That's where Carnegie Mellon University is, which is the university where I work. The last 2 weeks, what we did is we had, last 2 weeks we had some actual problems that came from some contests. How do you prove the angle bisector theorem? Okay, well let's try playing with this. And what you'll see now is I actually don't exactly remember how to prove the angle bisector theorem. Let's go and see what happens if we try to stare at a problem and figure it out. As in, I probably could try to, I could probably prove it in some complicated ways, but I want to know if there's like a nice way. Let's see. So what's the angle bisector theorem? Angle bisector theorem, you draw a triangle, okay? And then you bisect the angle. Is that a bisection? That doesn't look quite like a bisection. Bisecting the angle, that doesn't either. Bisecting the angle means that we're cutting it into two equal angles. That looks more like it. So these two are the same. And the angle bisector theorem is talking about what happens when you are looking at some of the side lengths. Suppose we call this A. Suppose we call this B, and let's call these other two parts C and D. And the angle bisector theorem tells us this. It tells us that A over B is the same ratio as C over D. Okay, I have now seen that my board has gone nuts. Let me adjust this right now. So what happens whenever I come back into the studio after a while is I sometimes have to reset the sizes. Just a second. That was huge. Getting close. Good. Great. There we go. So I just adjusted this. Let's see. So angle bisector theorem is talking about the ratio between two sides and the ratio that it splits the other part into. How could we go about trying to solve something like this? Okay, so there is actually a way to do this, which is based on what's called the law of sines. Now, I'm trying to think if there's an easier way to do it besides using the law of sines, because that's a, well, let's put it this way. So there is something called the law of sines, which talks about the sine of an angle, and that uses something called trigonometry. And the reason that works is actually because the sine of this angle and the sine of that angle are equal. So that's one way of solving it. But now, if I want to solve it without using the law of sines, I wonder if there's another way that I can do this nicely. And I'm trying to think of a way to do this where I'm basically proving the law of sines for you. Wait, I see it. Oh, it's that easy? Okay, I actually don't remember the proof of the angle bisector theorem being this easy, but let's just do this, okay? What I'm going to do is I'm simply going to draw the heights of those two little triangles that I've made. But I'm going to draw the heights in a funny way. Here's one height, and here's another height. Oops. Let's come from here. Do you agree that these are two heights? Yes, these are two heights. So if we look at like this triangle over here, it's got base B and height this thing. And then this triangle over here has base A and height that thing. Why did I do this? I did this on purpose because can you tell me anything about those heights? They look awfully equal in length. Well, they are. And the reason they're equal in length is actually because of a concept called congruent triangles. You see, there are these triangles which are right triangles, where one side is this pink thing, like here's another one. They both have the same hypotenuse, which is right here. And they actually both have the same angle, over here and over there. Let's, well, I don't know if I want to draw more letters. That would just make it more confusing. I'll use my hands. This triangle right here is actually congruent to this triangle right here. Congruent means that they're the same triangle. I can get from one to the other by rotating or flipping or moving. Well, if these two are congruent, and they are congruent because you can imagine that you just reflect it over here and it's like a mirror. This is like a mirror here. And it's the mirror is here and they have the same angle there, so then these two heights are the same. Let's call them both h. Now, why did I do that? I called them both h because now I can say something about the areas of those two triangles that I've cut this big triangle into. Let's draw the two triangles first with some colors. Here is the blue one, and let's draw another one, which is like the pink one. Okay, so I have these two triangles, blue and pink. What's the ratio of their areas? Well, there is one way to do it, using the fact that we have the heights. Okay, I can talk about the areas of the triangles. I'll say blue area is equal to 1/2 base times height. I want to make the numbers a bit nicer. I mean, by drawing a bit nicer. It's 1/2 of the base times the height. And here I'm thinking of this as the base, and the height is h. Okay? Well, that's the blue area. How about the pinkish purple area? Well, the pink area is going to be 1/2 of the base. Now that's b for the base times the height h. Now, why did I do that? I did that because I can look at the ratio. What's the ratio between the blue area and the pink area? Well, if I just divide these, the ratio is just a over b. So these are in the ratio of, I'll write it this way, blue is a. We draw a colon to mean like it's something is to something else, and b. Well, that was nice. So the ratio between these two areas is just a is to b because they both have those two different bases, possibly different bases, and they have the same height. Aha. But why is this good? The reason this is good is because there's another way to say the ratio. Does anyone see what that is? Do you see what that is? The way to find the ratio between these two, there's another way. It's that I can think of these two as having the same height, which is going up this way, and the base of the blue one is c, and the base of the pinkish purple one is d. So there's some other height here. Let's call it capital H. Okay? Yes, they have another common height. Let's call that other height capital H. So h is this height. Okay? And so there's another way of thinking of these two areas. The area of the blue one is also 1/2 times the base is now c times the height is now capital H. And the area of the pink one is 1/2. The base is now d and the height is now capital H. Okay, well, the ratio between them is then c is to d. I'll draw the colon first. And so it's c is to d. Okay, that's it. That's the angle bisector theorem. A is to b and c is to d are the same. That's exactly what's here. So I guess this is the simple proof of the angle bisector theorem, showing that I guess I forgot what it was. This is so simple, it's probably what's in every geometry textbook. But you can also see the way I think through things. I'm just like, well, you know, even if I don't know how to prove this, let's just try to figure it out. And if you can see the thought process I used, is I guess I recognized something called law of sines. But then I thought to myself, why is the law of sines true? And I was like, oh, sines, that's trigonometry. People are talking about trigonometry in the chat. Trigonometry is when you talk about ratios, like the opposite side over a hypotenuse. So I said, let's make some right triangles. And that's how this idea popped into my head. So thanks for asking that question. This is how you can prove this angle bisector theorem, which is quite powerful. Okay. Now we've got some other questions. Questions have appeared. Oh, this ends at 8:45, right? Yes, this ends at 8:45. So it ends in like 35 more minutes. Somebody has asked where Debbie is. Debbie is actually not in today. And so I am the person who's looking at all the comments and trying to figure out what to say. Oh, I see. Cyber City Citizen says AOPS has another proof based on similar triangles. You see, I remembered seeing somewhere there was some other proof based on similar triangles, but as I was just staring at this problem, this is what popped in my head, and it actually looks quite simple. And I guess maybe I won't forget it again, because this is something that I figured out on the spot. And by the way, that's a good way to learn math. If you go and take a theorem, instead of just reading why it's true, if you go fight with it for a while, after you do it, you will be more likely to remember. Okay, more questions. Somebody wants me to crack Albert Einstein International Scholarship Test. I don't quite know how to do that, but all I can say is if you want to do well on these kinds of tests, go think about hard questions. You know, this can be hard to you, and then as you think about it, you figure out how to prove it yourself, and you're good. Oh, sir, can we find a general formula for 4 or 5 degree polynomial? Yes for 4, no for 5. And this is a famous fact in more advanced mathematics, that there's a quadratic formula, a cubic formula, and a 4th degree formula. But it's provable that there's no 5th degree formula that just uses these kinds of square root, 4th root, and so many roots symbols. But that's beyond the scope of this particular live stream. Oh, okay, what's this? Math Jedi has a funny question. X is a positive integer less than 1,000. X is positive integer less than 1,000. Okay? And what are we supposed to do with this? X squared leaves a remainder of 9 when it's divided by 341. X squared divided by 341, remainder equals 9. Okay? And the question says, what's the largest possible value of x? I picked this one because I don't know how to do it. That's how I always go. I see, meanwhile, Toady Master says he or she had to wear a green shirt on Friday for School Spirit Week. Someone's making a hint that they don't like the color of this shirt. But okay, let's try. So if I have x squared divided by 341 has a remainder of 9, here's how I would write it. At first, I don't exactly know how to do this question, but that means that x squared minus 9 is a multiple of 341. Oh, now I like that. The reason I like that is because x squared minus 9 factors. So a little bit of me, the math contest problem radar, is saying whenever you see a difference of squares, knee-jerk reaction, factor it, and then see what happens. Okay? Toady Master said he. Awesome. So then what we have here is a multiple of 341. Second knee-jerk reaction, look at the number 341 and be like, is it prime? Do we know any divisibility rules that will work with this? And I actually see that it's something times 11. Multiplying a number by 11 is very nice. When you multiply a 2-digit number by 11, you just write the 2 digits and you put the sum in the middle. So that's 31 times 11. And if you didn't know that before, it's easy to check. If I just try to multiply 31 by 11, you see what's going to happen. If I do 31 times 11, well, I get the 1, 3, and another 1, 3. So what you're doing at the end, you have the 3 in front, you have the 1 at the end, and you do write 3 plus 1, which is 4, the sum in the middle. So, okay, we've got this. Now, this is nice because if I want something to be a multiple of 31 times 11, now those are both primes. The only way you can be a multiple of 34 times 11 is if you're a multiple of both 31 and 11. So what this means is that between the x minus 3 and x plus 3, I need to be picking up a factor of 31, sorry, a multiple of 31 and a multiple of 11. So what this means is that 11 and 31 divide in here. Okay, well, if that's the case, now I need to find a large number, a big number less than 1000, so that I have multiples of 11 and multiples of 31 which are dividing into here. That's making me want to know, what are some really big multiples of 11 and big multiples of 31 that are close to 1000? Now, when I look at this, let's start with the 11. I'm just curious where the multiples of 11 are out there. And there's a very nice number close to 1000 that is a multiple of 11. It's one of my favorite numbers. One of my favorite numbers is that 1001 is not prime. You see, if I take the number 1001, it turns out to be, it's a very famous factorization, 7 times 11 times 13. If you don't believe me, here's how you check. Let's just take 7 times 13. Oh yeah, we can practice the multiply by 11 trick. If I multiply 13 by 7, that doesn't look like a 3. Let's try it nicer. 13 by 7, 21. That was supposed to be a 2. That was something's wrong with my pen today. I think it's because I took it out. Whoa. It doesn't like drawing up there. One moment, please. I'm just going to switch this a little bit. You see, I was actually just on a trip, so I wonder if what happened is I forgot to make the pen. No, it's okay. I thought I forgot to turn off the touch on the screen, but let's go back. I think what this means is I just need to go and wipe the screen to make it cleaner. But I'll just say I know what this is. This is 91. Okay, let's write that down. And if I take 91 times 11, how do you multiply 91 by 11? Well, let's do it. Let's just not draw too high on the screen. Maybe that's the issue. 91 times 11, well, when you multiply, 1, 9, 1, 9. As you can see, there's a 9 and a 1. And a 9 plus 1 is 10. No, you can't do that. It's not that way. The 10 carries, right? So that 10 becomes 1, 0. And just kidding, that wasn't a 9, but that becomes a 10. 1001. Beautiful. So I now know these I know that a multiple of 11 can go up to 1001. All right, so let's just make a note. Multiples of 11 near 1000, because that's what we care about. Remember, we're allowed to do all the way up to x plus 3. So my number x plus 3 could go up to 1003. So in that case, if I go back over here, I like it. Somebody said it's 9101. But anyway, going back here, multiples of 11 near 1000. Well, I can get to 1001. And let's now subtract a bunch of multiples of 11. Well, let's now subtract 11 over and over again. So I get 990. Oh, that's obviously a multiple of 11. Look at that. That's just 90. That's 90 times 11. Subtracting another 11, 9. Yikes. Is that right? 979. I'm testing the multiply by 11 trick, and if it's 89 times 11, that would give me an 8 and a 9. 8 plus 9 is 17. That carries the 1 over to the 8, so 879. That's 979. So that's a multiple of 11. And now it's easier. 968. I don't know if I'll have to keep going down. I now need to look and compare this to multiples of what number? 31. What are the multiples of 31 which are close to 1000? I happen to know what 31 squared is. It's 961. And we can always check. What's 31 squared? Let's do it this way. If I want 31 times 31, that gives you 1339, 961 indeed. So that means multiples of 31. Let's write a list. So multiples of 11 near 1000. Let's make another list. Multiples of 31 will be blue. Of 31 near 1000. Well, I know that 961 is one of them. Okay, and I guess I'll try adding 31. That gets me to 992. And I guess I could go down. That's 930. I don't know if I'll have to look at more of them, but that's all of the multiples of 31 up until 1002, because 1003, that's the biggest I'll ever get. and multiples of 11 up to 1003. So now all I have to do is I have to say, is there a value of x? So that x minus 3 and x plus 3 pick up multiples of both of these. The key is that this is just two numbers that differ by 6. So I'm curious if on my list there are any two numbers that differ by 6 or are repeated. No, there aren't. Are there? 992. Oh, that's annoying. 992 does not differ by 6 from 990. That differs by 2. And the 979, that doesn't differ by 6. Oh, I'm seeing a pattern though. Am I seeing a pattern? I'm not sure if I am. But I see the 968 and the 961, they differ by 7, which is too bad. Okay, so in that case, what should I do? I guess I have to just keep going down now. So now I'm looking for, as soon as I get a number that appears on both lists, well, that could be one of the numbers. I have an x plus 3 and I have an x minus 3. I'm okay using one number to eat both the 11 and the 31. But, wait, is 31 what I want? Yeah, it is. But I can also get both of them by using two numbers that are exactly 6 apart. Well, let's see. Any hope? Well, let's just keep going. 968, 957. I'm going to continue jumping over here. This is just greens are the multiples of 11. 946, 935. Every time I'm checking to make sure I didn't make a mistake. Okay. Do we have things that are that close together yet? Well, I'm also curious how close I'm getting to these things. Like the 992, I'm off by a 2 over there. The 961, I'm off by 4 from over here. And off by 7 from over there. We got to get here soon. 930, I'm off by a 5. What happens if I drop another 11? 924. Oh, look at that. 924 is exactly 6 away from 930. Bingo. So what we have here is that, you see, I'm basically going downward from the top in terms of multiples of 11, multiples of 31. The 31s are actually fewer and farther between. So I'm basically looking at the multiples of 31 and seeing what are the multiples of 11 that are close by. When do I get something that's 6 apart? And here I don't. At the 961, I get these two. So 7 apart on one side, 4 apart on the other. But the 930, I have 5 apart on one side and 6 apart on the other side. So that means that these two are interesting. They're 6 apart. If they're 6 apart, then one of them is going to be x minus 3, and one of them is going to be x plus 3. That means x, I will want x to be right in the middle. So I'll use x to be halfway in between, 927. So that's my answer for this question. I don't know if that's actually the right answer. I guess we could check. Is 927 squared, when you divide it by 341, is the remainder equal to 9? I don't know. We'll find out. Hopefully someone here is connected to a computer. Actually, you probably are all on the computer, because otherwise you wouldn't be able to see me, right? So if somebody could please just go and check what happens if I take this number 927 and square it, and then divide it by 341. What kind of remainder do you see? Do you get 9? We'll find out. Hopefully somebody in the chat's going to go and check. There's this website called Wolfram Alpha, which is pretty good for checking these things. Meanwhile, I'm fairly confident this is probably correct. So let's go on and look at what else we have here. Wow. A man purchased a cow for 3,000 rupees. That's a very good deal for a cow, I think. If I do the conversion correctly. 3,000 rupees for a cow. That's pretty good. Are you sure you can get a cow for 3,000 rupees? I'm not sure. Oh, what is the question? The question is this one, right? I'm guessing that 927 works. And the question is, if I square something, divide by 341, is the remainder equal to 9? Meanwhile, other questions. What is my favorite anime? I actually don't watch anime, so I don't know how to answer that question. Yes, Energized Panda has used the Google conversion and found out that you can get a cow for $40.04, which is a pretty good deal. Because, yeah, I somehow think that you're off by maybe a few orders of magnitude, but that's okay. So over here, it's like, what is this question? Allowing the buyer a credit of 2 years, interest rate. The man has a gain of. Okay, so I'll say that's a fairly standard like interest rate problem. I would I mean, you just kind of multiply the interest rate 1.1. So 10% per annum is multiply the amount by 1.1. That's how I would do that particular question, allowing the buyer a credit of 2 years. So if I was just doing this in my head, I would say you take the 3,000 rupees, you multiply it by 1.1, and then multiply it by 1.1 again. And that's how much you have to pay in the end. So I'm just doing it mentally now. 1.1 squared is 1.21. And then that means that 1.21 times 3,000 is like 3630. The man has a gain? I don't quite understand. So the man has to pay 3630 eventually. So it looks like the man is losing 30 rupees to me. So this particular question here is saying 2 years and the interest rate is 10% per annum. So it looks like the amount that the man is going to have to pay back. I'm just looking at the question in the chat here. The amount the man has to pay back is going to be 1.21 times 3,000, which is 3630. And the man sold it for... Maybe I just don't understand the question. Oh. That allowed the buyer a credit of 2 years. I'm afraid I'm sorry, I just don't understand the question. I will say that if you are able to buy a cow for 3,000 rupees and sell it the same day for 3,600 rupees, this is good. You've just earned 600 rupees. But I think I don't understand the rest of the question. So maybe I'll move on to another one. Okay. What country is the currency from? Oh, that's India, I believe. RS is, I think it's rupees. I think it's India. And judging from the name, it looks like it might be from India. Okay. And thanks for other people for confirming that the answer was correct. Ooh, we're doing number theory today, I guess. Somebody said, what is the remainder when 53 times 103 plus 103 times 53 is divided by 39? So the question seems to be two of these. There's two of these. 2 times 53 times 103. I can write neater than that. 2 times 53 times 103 divided by 39. Divided by 39, the question is what's the remainder? Okay, well, if I see something like this, what should we do? We should take out all of these complicated numbers and already replace them. Oh, it's 53 to the power 103. I just can't read. No wonder it's not 2 times. Thank you, everyone. So the question is more complicated. 53 to the 103 plus 103 to the 53. I'll write it as mod 39. I'm first going to look at this and say, do we really want to do this question? Because I will say, I don't actually know if these questions have nice answers. Sometimes when people post a question into this, they just like type something in. And I will say there are questions that look like this, where sometimes it's very bashy in the sense that there's not a nice way to do it. But when I'm looking at this, I'm just going to try to see, are there any potential nice ways to do this question? The first thing I'm going to do is I'm curious if there's anything special about the number 103 when I compare it to 39. So what are some nice multiples of 39? 39 times 2, that's like close to 40 times 2. So it should be 78. Not very nice. If I take 78, 103 when I divide by 78, sorry, when I subtract 78 is like 25. Yuck. Is that right? Yeah, it's 25. So here's what I'm doing first, right? I'm just like, if I wanted to do this, what I can do first is I can say it's congruent to mod 39. Let's take 53, reduce it mod 39, and when I reduce it mod 39, that means I subtract off multiples of 39 from the 53. Subtracting 40 is easy. That gives you 13, but I need to subtract 39, so it's actually 14. So it's 14 to the 103 plus, and this 103 gave me a 25 to the 53. So far, so bad. But let's see. There's something else I could also do. I'm trying to think if this would actually solve the problem. So there's something nice about 24 in this. But that's not nice either. So what I was thinking about is that there's a theorem called Euler's theorem, where if I want to know what is the remainder when I divide by something, it turns out that when you take powers, you cycle. And you cycle after, in this particular case, it's after 24 times. It's called a Po-Shen function. That's what people are saying. Yes, yes. Maybe let me just tell you what I was doing. So this is now like pretty sophisticated stuff, but there's something you can do with modulo 39, which is that the number of numbers in the set 1, 2, up until 39, which are relatively prime to 39, is, now relatively prime means that there's no common factor between that number and 39. And I actually teach this in my number theory course online here. But this is a short live stream, so I can't teach the whole reason to you again. What you do is you take the 39 and you prime factorize it. And in this case, because I have two different primes, then the answer turns out to be subtracting 1 from each of those primes. Again, and multiplying. And again, I explain how this is done in our proper course. But here, I'm just doing a quick live stream. So that's the answer, 2 times 12 here. And it sort of makes sense because it turns out if I want to know what the remainder is when I divide by 39, it's determined by the remainders modulo 3 and the remainders when I divide by 13. And if I want it to have no common factors, I want to have remainders when I divide by 3 of only being 1 or 2 and not 0. So you only have 2 choices, not all 3. And remainders when I divide by 13, I don't want to have 0 as a choice. I just want to have 1, 2, 3 up to 12. So that's what this is. So it's 24. And there's this Euler's theorem. Euler is spelled this way, E-U-L-E-R. Euler's theorem says that if I have a number a and I raise it to the power 24, that has the same remainder as 1 mod 39 whenever a is relatively prime to 39. Okay. And so what that lets me do is it actually lets me reduce these things down by subtracting multiples of 24. Because every 24 is 1. Energized Panda says, hold up. 14 squared. Oh, somebody got excited. Okay, so maybe there's something nice here. Oh, wow. So the great thing about having a very energized audience, such as Energized Panda, is that while I'm messing around with this Euler's theorem, somebody has noticed there's some neat patterns. So, for example, it turns out that 14 and 25 are both nice numbers. And this Energized Panda has just said, look, 14 squared is equal to 196, you mean? Yeah, 14 squared is 196, okay? Because I've got powers of 14. So let's go and take 14 plus 25 equals 39 is help. Did I screw up? Maybe I did. But let's keep going. So I'm not exactly sure what Juliet Z is talking about in terms of did I make a mistake? Maybe I did. If so, please jump in and correct. But what we're seeing here is that these are powers of 14. I don't know what is 14 when I divide by 39, but I could look at 14 squared and hope that looks nice. And 14 squared is a nice number. 14 times 14 is 4, 4, 16, 56, 1, 4, 196. And there was this observation that if you take 39 times 5, 39 times 5 is close to 40 times 5. 40 times 5, that's 200. Close to, meaning I should drop 1 5 times, so 195. So what that means is that actually this 196 is 1 mod 39. Okay, I'm not sure about the -1 that you have said there, Energized Panda, but it was a very good clue for me because this helps me a lot. It turns out that 14 squared is going to be 1 mod 39 because 39 times 5 is 195, which is just 1 less. So fun fact, 14 squared is already 1 when I divide by 39. The remainder is 1 when I divide by 39. Oh, wait, what's Euler's theorem again and how do you prove it? So Euler's theorem says if you take any number which is relatively prime to what you're dividing by, and then you raise it to a power, where that power is how many numbers from 1 to that number are relatively prime to that number, that modulus. Then anything to that 24 in this case has a remainder of 1 when I divide by that modulus. And this is called Euler's theorem. The proof I actually prove in my online class in number theory, but you can also find this all over the place whenever you, I guess, go searching. but it's just called Euler's theorem. If you hunt for it, you'll find it. So we have this thing here, and it only works if A is relatively prime to 39, or else you would actually always have a remainder, which is a factor of 39 inside. Okay. Silly on the post, hey, Energized Panda, don't worry about it. You gave a great hint. Because 1 is already wonderful. Because 1 is wonderful. Did you get it? Anyway, that was an unintended pun. But like over here, this gives me a 1. I love 1 because then I don't really care. I just like take this power 103, but every 2, it's going to go, it's going to repeat. So if I take this 14, powers of 14 modulo 39, it's like 14, 1, 14, 1, 14, 1. I like that. How about 25? Now you got me excited. So let's see what are these powers of 25. 25 squared, I know. That's 625. And what's 625 mod 39? Let's find out. Well, long division time. Divide by 39. What's going to happen? Okay, so I take one of the 39s. Subtract. 12 minus 9 is 3, 235. Oh! I see a 240. That's like times 6. Okay, so let's try times 6. What happens? 6 times 9 is 54. 6 times 3 is 18 plus 5 is 23. Bingo! 1. Remainder of 1. So that means that 25 squared is congruent to 1 mod 39. This problem wasn't that bad after all. Okay, so in that case, I can go back here and say, well, I know that I'm taking 14 to the power of something, 25 to the power of something, but every even thing it resets. So actually, modulo 39, this is just 14 plus 25. Oh, I get it. That's why there was a person who made the comment inside that you just add 14 and 25. You were just many steps ahead of me. I was too slow. But continuing this, now that means this is just congruent to 14 to the 1 plus 25 to the 1 mod 39. I didn't even need Euler's theorem. I was expecting to use Euler's theorem to subtract down the powers. But now I just need to know what this is. What's 14 plus 25? Oh, come on. What? It's 39? So the answer is it's just a multiple of 39? So, did I do that wrong? 14 plus 25, that's 39. So the answer is 0. 0. Ooh. 0. Is that really true? Can somebody go and check with Wolfram Alpha? If I just take 53 to the 109, 53 to the 103 plus 103 to the 53, is that actually a multiple of 39? That's super cool. Yup. Okay, I see Toady Master has already said, yup, I already did it. So I guess that's right. All right. Thanks, crowd. You guys are good. Okay. What other questions do we have? I'm just checking here. I don't have any moderators. I have no moderators tonight, so it's just me. All right, it is true. Nice question. Thank you very much for suggesting this question. I did not know what was going to happen. All right. 8 minutes left. That's right. We only have 8 minutes left. I see that David Hall has asked a question. It looks more sophisticated than what I wanted to talk about here. Let's do something simpler. Because I've been talking about things that are pretty deep so far, I want to make sure that we don't go like way off track with this particular live stream and just get too hard. Avik Sarkar has asked, well, if x squared is 25, then x could be plus or minus 5. But then why do you only write square root of 25 is equal to 5? Because it could be minus 5 also. The reason is because we just want to have some consistent notation. And so it's useful for us to be able to write that the square root sign is always going to be the one that is positive or 0. That way, if we ever want the negative one, you just write minus square root 25, and it's determined. This way, when you write one symbol, you really get one number, unless you really want two numbers, and you write the plus or minus sign in front. Okay, more questions. Somebody has said that, sir, 9 months are left for IMO. If someone is good enough to make bronze medal now, can he be prepared enough to make gold? Well, he or she. Well, I would say, you never know. I think that if you work hard on something, you might be able to learn lots and lots of things. And so the answer is yes, it could be. Main thing is that make sure that while you're learning, you just make sure to keep doing questions and thinking about them carefully instead of just looking for somebody to feed you things. Somebody said, I have school tomorrow. I don't want to fry my brain already on a Sunday. Yes. Okay. Oh, the Math Jedi. Triangle ABC has medians of length 12 and 15. What is the maximum possible area of the triangle? I'm not sure we'll be able to do this in 7 minutes. I'm just going to write this thing down. Medians of 12 and 15. This thing sounds like it would be too complicated to do in a very short time, but I want to just record it. I mean, I just want to write it down because I want to stare at it and maybe do it next time. 12 and 15. Oh, do I have an idea? Maybe I have an idea. There's something nice about medians. Medians of a triangle always cut each other into thirds. So actually this 12 and 15, this is a 8 and a 4. And the 15 is a 10 and a 5. Okay. But they have to be medians. So that's still not so nice. Yeah, I'll say I don't immediately see how to do this thing right away. In the sense that I think this is a really good problem. I want to save this one, okay? So I'm just going to say this is a very interesting question. Let's save this one because I think it deserves a more proper discussion. I like this one. Okay. Yeah, I like this one. It's just that I don't want to have to attempt to do this in just 4 minutes and like talk too fast inside here. It's a really nice question because it makes me think of, like, you know, as you start moving these medians around, how do they stay medians and all of these things. Can we do AA? Maybe, but let's save this particular question. Other questions, what else do we have here? Oh, ask anything. Yeah, you can ask anything. That's probably a good way to go. Because again, we did some good math problems already today, and this is an example of another good math problem that I'd like to save. Please, next week, remind me of this question. Oh, I'm not sure if I'll be here next week. We'll see. I might be going to Brazil next week. I haven't figured that out yet. I will know next week. But if I'm here, I'll do this question. Otherwise, we'll have to wait another week. But yeah, you can ask anything. Brazil. Yes, that's right. More questions. Let me scroll up just because I don't know if there were things that people have posted that I just didn't see. Save the question. Do you know two-set violin? I don't know. Ah, Lucas, where are you in Brazil? I haven't figured that out yet. So the real reason I'm going to Brazil is because the Brazilian Math Olympiad training program wanted me to stop by and give a talk. But I don't want to just go to Brazil to just go to one place and give a talk. So I actually reached out to some other universities. There's a University of São Paulo and a IMPA, Institute of Pure and Applied, Institute of Mathematics, Pure and Applied, something like that. So one is in São Paulo, one is in Rio de Janeiro, and I might be giving some kind of a seminar in each of those places. Haven't figured this out yet. Oh, you're from Brazil! Wonderful. And so I don't yet know. My goal is that if I was going to go to Brazil, it would be to go and give some seminars at those two universities about the work we're doing to fight pandemics, which is applied mathematics, and then also to visit the National Math Olympiad training program and say a few things too. Okay, the Math Jedi. How do you work on your speed for math competitions? Bring you a souvenir, awesome. Okay, how do I work on speed for math competitions? I'll just say, I think that if you are doing questions where you think a lot, you'll get much better at thinking, which is the hardest part. And then as you keep thinking about these things, if you spend the time, you will get faster. If you can see, also, there's another funny thing. Oh yeah, this is interesting. I don't know if you ever play any of these like games where you have to buzz and hit the question as fast as you can. But I found out that for me, I do well on those games, not usually because I'm the fastest right away, but because I just don't get it wrong right away. It's very easy to silly mistake as you're doing things too fast. So for me, the way that I try to make sure I can be fast is by, as I'm doing questions, like mentally checking that they're right while I'm continuing to speed ahead. So what I mean is, for example, when I was doing, even this, as I'm writing down this sequence of numbers, each number I wrote down, I kind of looked and I was like, do I believe that's a multiple of 7? Multiple of 11. Can I see why? Can I see why? Can I see why? That's how you actually get accuracy and speed at the same time. Because a lot of people, if they speed too fast, you just lose all of the accuracy. And then that's it. Yeah, exactly. Energized Panda, you mentioned for the win. That's one of these ways that you play things fast. Or when I was young, I was like also practicing these math counts countdown round problems with my younger brother. And we just, you have to be fast, but you need to be able to be fast and correct at the same time. Limit x tends to infinity of bound function's derivative is 0. But why? Well, it's actually not true. If you have a bounded function and it's the sine meaning it just keeps waving like this, the limit of x, the limit of the derivative is actually not tending to anything. So I think what you mean is a bounded function which keeps going in one direction only, then it's true. But that's because there's no space for it to go into. Right, that was a calculus question. So unfortunately, this is beyond the scope of what we were talking about here. Oh, and unfortunately, it looks like we are out of time. Last question, how's Novid going? Yeah, that's why I might be going to Brazil, right? It's just, how are we going? Well, more and more scientists are seeing that there's some value in what we have invented, which is a new way of fighting disease. With that, I think I will answer the question, do I like instant ramen? I actually do, and then I eat a bowl of it, and I find out after I added the whole packet, it's too salty, and then I don't quite like it as much anymore. But I guess I like it. I like it as well. Yeah, that's a way to end. Awesome. Well, in that case, thank you everyone for coming to Ask Math Anything or have any ramen that you want. And I'll see you again either in 1 week or 2 weeks. Take care. Bye-bye.